All right, lab, we'll be setting up Linux in a VM environment on Mac so that we can do the rest of the labs to build our OpenGL 2D pixelated breakout game. All right, so you don't have to use VMware. You could use Oracle VirtualBox or any other virtual managing software. I'm just going to show through VMware. They make you jump through a couple of hoops here, but for the Mac, what we need is VMware Fusion. And all right, so it'll go here to get your license. And if you click on download a free trial, so I started at VMware.com and clicked on the downloads and then Fusion, and then it took me to here, and then download a free trial. And then when it comes over here, it'll say Fusion 12 player, register for a personal use license. So click on that. I don't know why they open a new tab for everything you click on. So you would go to create an account if you haven't done this before. I have an account, so I'm just going to log in with that. When you do create an account, you'll use like your Eagle email, and it'll mail you, and you'll have to do a verification and all that. But then once you come in, you'll get requested and you'll get a license key. You'll need to keep this license key, so I would suggest copying it and putting it like in a text editor, and then you can manually download, click on the manually download to download Fusion. And then you need to download, and I'll have a links for all this, but you'll need to download from releases. I'm going to show you Ubuntu. Now, if you already have this stuff set up, that's great. You don't need to do any of this, but from the releases, you can see all the releases that are out. I went ahead and deleted the newest one, Groovy Gorilla. So you'll just go in, and I'm going to cancel this, but actually I won't start it, but you'll just download this 64-bit PC AMD 64 desktop image. This will take a while to download. It's about 3 gigabytes. And so all you do is have to click on this link and it'll start downloading. And if I look in my downloads folder, let me see, how do I get the list? You can see it's about a 3 gig file. So this will take a while to download, and then of course you can download the VM Fusion. It comes down very quick, and you'll execute that. You don't execute this ISO. You just need to hold. You'll leave it here in downloads. All right, and then once you have all that downloaded, you want to start a new. You'll do a new, and it'll look like this when it first comes up. So I'm going to close this other one. So it'll look like this, and you can just do create a custom machine. And then we want to pick Linux and Ubuntu 64-bit. And then I just left the defaults for this. And then create a new virtual disk. Okay, so in here, I'm going to click on Customize Settings. We're going to save this. So this will be the computer name. So I named it Ubuntu.20.10 because that was the version I downloaded, but I've already named one that. So I'll name this one OpenGL. Where this is in virtual machines, I believe is in your documents, virtual machines, but I just left it default. And then I said save. All right, and then now when we come in here, we just have a couple of things for processors and memory. Mine came up with 2 cores. You want to at least have 2 cores selected. Memory, at least 4 gig, 4 meg of memory. Anything, it's great if you have a lot of memory, you can obviously do more, but we don't need a whole lot for what we're doing. We don't need any of that. You can click on show all to go back as you edit these. For the hard disk, SCSI's fine, but make sure you uncheck split into multiple files. It'll give you a lot better performance if you don't let it split it into multiple files. In other words, keep it one file. I left mine at 20 gigs. That's way more than enough for what we need, but and then go back to show all. And then for the network, I think, you can leave it here. On Windows, you usually need to change this to a bridge, but in the Mac, it seems to work fine. So show all. For the CD-ROM, here we can say connect to DVD drive, and we can choose a disk image, and now we can go to downloads and choose that Ubuntu ISO file. And that's the disk image for Linux. All right, and then, so that should be it for this. I'm going to hit close, and now we can start it. All right, and then we want to load Ubuntu. All right, so let's see, I think it's going to come up here pretty fast. Okay, and so English, and we just want to install. English and English. All right, normal installation, download while installing. That's good enough. All right, we want it to erase the disk and install. Remember, this is a virtual disk. It's not your actual hard drive. So if you continue, all these changes will be done. That's good. Continue. All right, New York is good. And so let's see. And this will be Ubuntu 20.10 username. I'm just going to put login automatically and do continue. All right, so it's done installing. I'm going to go ahead and do the restart. It may warn you about removing the media, but you don't need to worry about that. You can just hit enter and it'll eject it when it reloads. All right, and once it's back up, let's just make it a little bit bigger. Don't need to worry about any of this, and no, I'm not going to send any information. And I don't care about the private location services. This is all great. There will be some updates. I'm going to hit done, and typically it'll determine that there's some software to update. All right, and the catalog's been built, and then it'll have, typically in the software updater, there'll be some software you can update, and you go ahead and just do install now. It'll do all that in the background, so it's not a big deal. While it's running, oh, I didn't mean to click on that. We want CLion, so we can go ahead and install CLion. If we click up here in the search, you can type in CLion. And if you have not used any of the IntelliJ IDEA products, you'll need to register at some point. I'm going to just go ahead and download, but you can get all of the products from IDEA for free with your student email address, just with the .edu email address. So just go ahead and go out to JetBrains. Sorry, they also go by the name IDEA. But go out to JetBrains website, or I think you'll be able to do it. Let's see, I think you'll be able to do it. I'm going to click install, and then it wants my Ubuntu password that I gave. So I can modify, and it's going to go ahead and install that while the updates are also running in the software updater. So now we can find CLion. Don't start it yet, but we can find it here in whatever this is called. But we can see CLion there. But we need to get some libraries installed first. So what we need here is we're going to need a terminal. So just start typing terminal, and you can hit enter. And we need a terminal window there. And then we've just got a couple of things we need to install. We need to get a build environment. In other words, we need to be able to type GCC, and we should get a GCC, but we're not. So we need to install a couple of things. So we're going to start with the build environment, the essential build environment. I'm going to use something called sudo, which just allows me logged in as me to act as if I'm the root administrator of the computer, and it's going to ask me for my password the first time I use it. And then apt is for our applications, and then we're going to do an install, and we want the build essential, and it's not plural. And if I spelled it correctly, it's asking for my password for sudo to be able to act as root. Okay, and then, so now every once in a while you'll see where you'll have like this choice to make, and it says capital Y or lowercase n. So I want to put in a capital Y. And then it'll go through installing things. And like I said, I'll have each of these commands listed in the description of the lab video, so that you can actually just copy them and paste them right into your terminal window. All right, and so I'll usually hit enter a couple times to give myself some space. Next one, so I should be able to do a GCC version. And here we can see we're running GCC 10.2.0, which is perfect. Okay, so now we want to get, we need the CMake for, which is a C++ makefile for building programs, because CLion uses makefiles. And then we also want Git, so that we can download some Git repositories. So we're going to do both of those at the same time by doing a sudo. And the reason we're doing sudo is we don't want to install this kind of stuff just under our username. We want it installed at the system level, so you have to be root. So sudo lets us act as root. So apt get install, and I don't think it matters if you do the .get or just do the apt install, but we're going to do CMake and git core. So we're actually doing two things at one time. All right, once again, I see a capital Y, so I'm going to hit that. Sometimes those are the default choices. You can just hit enter, but I like to be sure, I like to go ahead and just type the capital Y to make sure. Right, and if any of these take too long, I'll pause. So you may see things skip by on my video, but I think it'll go pretty fast. All right, so now we have our make environment, right? And we can see that that exists and Git exists. So now we need to start downloading our OpenGL environment. So we're going to start with another sudo apt get install, and we're going to do 4 different libraries at one time. These are all going to have the libraries that we need for our two-dimensional graphics programming. So mesacom dev xorg dev lib glew, and this is a OpenGL extension library. And L, it's a dash lib glu1 mesa.dev. There we go. Capital Y. All right, these are pretty fast. It always amazes me how much gets downloaded when you do one of these super simple apt-get installs. But you'll see some X11 stuff going by. That's the Windows environment for Linux is X11. So OpenGL and the GLEW extension and all of that is all built on that X11. So we're downloading all of that stuff at one time. And you won't have to type these commands. I would suggest just copy and paste them right out of the window, right out of the description. All right, so now we've got the bulk of our stuff downloaded. We are going to set up a directory where we can download some Git repositories. So we're going to do an mk directory or mkdir for, let's just call it repos. And just before I do that, if I do pwd for our current path, our path working directory, we see I'm in my home folder, which is basically, if I open up a file explorer in Linux, I'm in home, and I'm in this path, and these are the folders I would see here. If I do LL for a long listing, I see all those folders, plus some hidden things with the dots. But I see like music and pictures and downloads and documents. So that's all these folders here. So I want to create a new folder in here, and I could actually do it graphically in here. I could say a new folder and call it repos, right? I'm not seeing it, but if I scroll over, there's repos. Well, the mouse got sticky on me there. Okay, so that's what we would have done with the mkdir. We could do the same thing here by doing mkdir repos, and that would create the same directory. But now that we have that directory created, I'm going to change into that directory. All right, and then so now we want to bring down some Git repositories into this folder. So we are going to do a git clone, and from the web, HTTPS, and like I said, just copy these right out of the description, GitHub. But if you want to go through the typing, just watch your capitalization and spelling. So we're bringing down another OpenGL extension library called glfw. All right, and that's there. And if we do another long listing, we can see that that folder came down, and the colors are terrible. So now we need to get a library that I built that's going to wrap all the OpenGL commands for us into just a couple of simple instructions. So we're going to do a git clone and then HTTPS, and this is going to be from github.com, Allen FGCU, and it's called FGCUGL. Alright, and then if we do another long listing, we can see we have FGCUGL and the GLFW. Now the GLFW, we actually need to compile it. We need to build it so that we get the actual object code library. So we're going to change directories into GLFW. So do cd GLFW. And then we are going to make a directory here called build. Alright, and once again, if we come back out here, we've got this repos. Here's the GLFW, and I just made this directory called build. Alright, and so now we're going to change directories into the build directory. Alright, now notice we're inside this empty build directory because that's where we want everything that we build to end up. But back up here at this higher level, this is where all of the code to build is. So we need to call this code out here to have the results end up in this folder. So we're inside the build folder, but we're going to run a build. We're going to do a cmake, but we're going to say 2 dots for the previous directory. In other words, run cmake against whatever's in the directory above me, which will be this make file here. Cmake list.txt is what it'll end up running. So I'm going to hit enter, and then it's going to go through and do all the compiling. And then now I need to run. Now inside the build folder, we now have another make set up. So this time we're just going to do, from within this directory, we're going to run a make. And that's going to build all the object files for the library. Okay, and then so if we look back here in our build, we now have, it's hard to see. Let me go back out and come back in. So, yeah, it'll all be buried in here, everything that we built. It'll all be down in here, will be the object files and all of that. So now from where we're at here, we want to now install this library into the root folders of the computer. So we're going to do a sudo make install, and that way it will now actually compile everything into the final libraries and store it in these root folders like user local lib, and there's our library right there for GLFW, and it's put some other stuff, header files into the include, and some make files and stuff like that. So GLFW is now installed for us as a library. Okay, so we are actually ready at this point now to set up a project. So I don't need this terminal anymore. I'm just going to shrink it down though. It's over here. And I don't need this file path. Well, I will in a minute. I'm going to go back up to repos because we're going to need to get to these 2 files right here. But actually, I'll go back up to home and let's start up CLion now. So down here in the applications, CLion is not up here. It'll start to show up on that first page after you use it a couple times. I'm going to double click it. It's important that you get all those libraries installed before you launch a project, because Otherwise, you have to create a new project. Okay, I confirm that I've read. I don't want to send any statistics. Okay, now if you have not created an account, you need to go out to, at this point, you have to go out to JetBrains and create an account using your Eagle email address or whatever email address you want to use. But then once you do it, you can log in. And activate it. And you can do the evaluate for free, and then it'll pester you for 30 days, or I don't remember how many days it gives you. All right, and now we have CLion. All right, and so we can start a new project. All right, and we're going to do an executable, C++ executable. And here's where it's going to put it. So, and that's fine. Home, CLion C IDE projects. And remember, this is a fictitious drive. So it's fine to just go with the defaults. And then, so let's call this Hello GL for our OpenGL. And you can just leave this on C++ 14. That's good enough. And then do create. All right, so once it's loaded, let's do close. We need to update this to our class template. And one of the things we want to do is we want to rename this file. So, and let me expand this. Here's that file over here in our project structure, but to rename it, if you right click it up here on the tab, you'll get a choice to, oh, it's running some things in the background. There we go. Now I can rename it. So it was still opening the environment. And so we want to name this based off our project. So I'm going to do all lowercase hello gl.cpp. And I'm going to refactor that. All right. And so we have this hello, this is our main application source code, and then we also have this make file. We're going to have to edit this heavily, but notice it's already changed the name of our source code file in the make file because we changed it here. All right, so we need our base class template. So I'm just going to do the simple one here. File is hello gl. Yep, that's .cpp, and then it's by CLion, and the organization is COP 2001. Our term is 2021-01, and our CRN, you're either in 104.10 or you're in 104.09. Just put the one that you're in, and then a description. This is demo hello world in OpenGL. Alright, and before we even do it, that's good enough to get started. Let's save what we got, and then let's just, it's got a base hello world here. Let's see if that's going to run. So let's do a build, do build project. Alright, and it built successfully. We would have seen a bunch of errors if it didn't. And then we can run, and you can just use this little run over here. And we got hello world came out into the console here, and it exited with a 0, which we see it returns a 0. So that's a good sign. All right, so before we do anything else, we need to get the FGCU GL libraries added to the project. All right, so it's telling us where it put this project, and that little tilde in the path here means your home directory. So home CLion projects hello GL is the root path. All right, so I'm going to go out here to this file explorer, and here's CLion projects. Notice I'm in home. Here's CLion projects, Here's Hello GL. Here's that Hello GL CPP file. That's where we need to stick our files. Let's go back to home and let's go into repos. Right, here's where we downloaded from Git. And we just need the two source code files, the header and the CPP. So I just left clicked and dragged over them, and then I'm going to right click and say copy. I'm going to go back to home into the CLion projects, Hello GL, and there's the CP. I'm going to paste them right here. All right. Now when I come back to CLion, it adds them into here. All right, so that's good. But now we need to heavily edit this CMake file. Right, so this has to be edited a lot, so or quite a bit. And so from the description out in the video, you want to grab this, the file to put in there. So stand by just a second. All right, so these first couple lines are fine. We're just going to replace this line. And just watch, we need to make sure that we get the name of these things correct when we replace. But I'm going to delete that, and then I'm going to do paste. All right, so that's everything I copied. And let's see, I meant to get rid of that line. I'll have that removed in what's out there on in the description that you'll copy. But so we've added, let me make this window bigger. Let me make my Linux bigger here. And then, oh, I think when I copied, I missed the S here. There we go. All right, so most of this should stay the same. Just look for, here's the name of our project in this file. And we just want to make sure that that's the name that we see here, Hello GL, and also here. So you can actually copy and paste. And then also, these are the main two files, but then this has to match the name that we renamed this to, which it does. All right, and all right, so that's good for there. Let's save this. So these lines were already in there. We just replaced the add executable that was there with this, all this code. And this will add in all of our libraries that we need for OpenGL, GLFW3, and GLEW. All right. So we'll go back to our main file, and now we can actually start to put in our application code. So we'll start with including the FGC GL library. So we're going to do an include, but this time we're going to use double quotes because the file that we want is actually in our local directory. So we use the double quotes. So I'm going to come down, highlight that, and hit enter, and it enters it for me. All right, and let's give a comment on these. Let's say this is our OpenGL library, and then up here, this is going to be our console or debug. All right, because we'll still do some debug statement. Matter of fact, we're going to leave this standard out here. So we still see that in the console window. I'm going to give myself a little bit of white space, and then we just need to go through a couple of steps to get our OpenGL to show. All right, we're going to start by, let's let's create a string variable, and we'll call it display. And notice it doesn't seem to like that. So let's tell it that this string data type comes from the standard package. And we'll call it display, and we're going to set it to, and that's the standard namespace, standard template library namespace. We know that because of the 2 colons that it's a namespace. So string is part of that. And we need to do hello OpenGL world. And it needs to be in all capital letters because our little pixelated 2-dimensional OpenGL graphics library can only handle uppercase letters, and I'll be showing you why later. All right. So let's change this to, I'm gonna actually cut this. And this way it's consistent with what I did in the other lab. So I'm gonna paste that code here. I can find paste, there it is. Remember, I'm not very good at the Mac, so I'm gonna get rid of, I'm gonna change this text here to say showing, and then we'll add an insertion operator here and put in display. And so we want to do showing, let's do a colon and a space. All right, remember what's here in console out will show up down here in the console window, not in our OpenGL window. All right, so now that'll give us a debug statement. Now we need to actually do our OpenGL. So we start by creating a window by opening an OpenGL window. So we are going to call some functions in the FGCUGL library, our namespace. And so we want to start with window open window. So you can just start typing and find it and use the arrow keys to highlight and then hit enter. All right, and it told us that we have, you can kind of see, we have some prompts we need to fill in. We need a width and a height. So let's just start with 200 by 200. And then what to put out. And we'll just say our display variable, which has that Hello OpenGL world. All right, and you can see there's an optional parameter on resizable. It's defaulted to true, and we'll just leave that. So we just need to end this with a semicolon. And then we need to keep this program alive, otherwise the window's going to close. So we need a while loop, and we'll be going over while loops later. But for right now, we want to say while not, and then from the FGCUGL namespace, we want to do window closing. So while the window is not closing, and then we come down and we create the body of the while loop. All right. So while it's not closing, we can draw our text on the window. So let's do FGCUGL draw, and we want to do draw text. All right, and we need to put it somewhere. And so what we're going to do is, if I pop up the calculator, not you. Calculator. All right, so I believe this is 19 characters, and all of our characters on the screen are going to be 8 pixels wide and 8 pixels high. So we have 19 characters times 8 pixels wide gives us 152 characters. Now we have a 200 pixel, or 152 pixels, and we have a 200 pixel width screen. So let's subtract this from 200. So I'm going to hit plus or minus to make this a negative, so I can add 200. And that gives us 48 pixels left over. And we just want to know how many to go over from the left. So let's divide this by 2. And that gives us 24 pixels. So we'll start out drawing at 24 pixels. That'll be our X. And then for our Y, where'd my calculator go? Each letter, all the letters are 8 pixel high, and we have a 200 pixel height screen. So let's subtract 8. That gives us 192 pixels left over. Divide that by 2, and we get 96. So let's say our Y is at 96, and that's from the bottom. So we're going upwards 96 pixels to the bottom of our characters. All right, and then the text we want to draw is in our display variable, our string variable. All right, and then now we need to actually paint this on the window. So FGCUGL, I think it's window paint. All right, and then we need to continually check for events So FGCGL get events, and you could just like start typing events. There it is, get events, and hit enter. All right, and that will check for the window closing or keyboard input or whatever. And then we can come down outside the loop. After the window does close, we need to do some cleanup. So FGCGL cleanup. All right, and that should be it. That should get us our first OpenGL window up. So let's save this. Let's do a build. All right, looks good. Let's run it. All right, so out here in the console, we got showing Hello OpenGL World. And then we've got our Hello OpenGL World in the title bar of the window because we passed that into the title bar. And we can see very small Hello OpenGL World exclamation point in the middle of the screen. All right, but it's really small. But let's go ahead and close the screen. When you're in this virtual environment displaying the graphics, it tends to kind of hang it up, and it's because this while loop is just flying around, eating up processing. All right, so that was good. Now let's just play around with this a little bit and say, well, what if we wanted to calculate what these positions were? In other words, let's do exactly what we saw our calculator, what we did manually with our calculator. So let's come in here and let's say we're going to have an integer, and we're going to say, and actually, well, yeah, let's make this a floating point number, float, and we're going to do our x, and we're going to set that equal to, oh, you know what, now I know what I needed to do. Before we do this, let's come up here above this part and let's do an integer, and let's call it screen width, and we'll set that equal to our 200. And then another integer, screen height, and we'll set that to our 200. And now what we can do is we can replace these. Let's copy that and replace that 200. There's paste. And copy. And I keep trying the Control V, Control C, and it doesn't seem to work. Let's see. Oh, it did work. Okay. And then instead of having this Hello OpenGL World in the title bar, let's do something different, and let's just do OpenGL for the title bar. Right? Now let's come down here and let's create some float variables, and we'll call it x, and we're going to set that equal to, we want to go through the formula that we did before. So we have the screen width, all right, and then we have that minus, and we want to do how many characters are in our display variable times 8. So we can do display dot length, and we can multiply that by 8. Right? And we don't really need to do any parentheses around this because the multiplication will happen before the minus, but we want to do the minus before we divide all this by 2. So let's put all of this into grouping, and then divide that by 2. And then we're going to do something similar. Oops, I forgot a semicolon. That's why it tabbed itself in when I came down a line. So a semicolon. All right. Oops. Now let's do another float. And we'll say y. And this is going to be equal to our screen height minus 8, because our characters are 8 pixels high, and then that divided by 2. Right? And then now we can just replace the 24 with x and the 96 with y. And nothing's going to change here. It should be the same exact thing, except for the OpenGL in the title. Anyway, let's build. All right, and then let's run it. All right, so we get the same thing. We see OpenGL now in the title bar. We see our message printed, and down here we see our showing Hello OpenGL World in our debug message. All right, so let's close that. All right, so now we want to make that text bigger. So let's come up with a scale property. Let's say we want to scale everything times 2. So let's do an int scale, and let's set that equal to 2. And then down here, let's make the screen that 200 times scale. So it'll end up being 400. And then same thing here, times scale. And then we'll scroll down here, and okay, so we want to do our screen width minus our display length times 8, and then we want to scale this. So really we want to do display length times 8 times scale. Now we could put parentheses around the 8 times scale. It's not really going to change anything though, but sometimes it helps you understand what you're doing, so it's worth doing it. And then if you wanted, you could even say, okay, well, it's trying to help me. You could say, okay, well, this is going to be display length times 8 times scale, so you would just do another set of parentheses, and all of that's fine. You can't go wrong with putting too many parentheses. So like if I do times scale here, in this one it's easier to see that the 8 times scale is going to happen before the subtraction. Okay. And then we still want to divide by 2 outside that. Okay, now the only thing is we want the text to draw larger. So if we come in here after our string variable display and put a comma, we should, well, we're not getting the help didn't pop up. I expected the help to pop up. There we go. Okay, that's on that. I hover over that. Here we can see in this window, we can see after the string called text, we have an integer variable called size, which is defaulted to 1. So we're going to replace that with scale, which we know is set to 2 right now. All right. So let's build this. Okay, and then let's run. Okay, and now we've got a screen twice the size and our letters are twice the size, and that's a little bit easier to read. All right, so one last thing, let's change the color of that. Let me close this, and if we look in this fgcugl.h file, the header file, we can see we have a couple of things defined for us. We have some colors, and notice everything's in this fgcugl namespace, but we have these colors. Then we have all these functions that we've been calling, like open window, window closing, window paint, get events, clean up, draw text, if we scroll down to the bottom, here's all the character data. So this is where all the pixelated hello world in uppercase is coming from. And we'll look at how that works later. But for right now, here's some of the different colors we could pick, like say maroon or magenta. And so let's come back here, and in our draw text, we have, if we hover over that, notice we have a float x, float y, a string called text, int size, and we have a color that's defaulted to white. So let's pick a color. So we just need to use the FGCUGL library, and then we could do like magenta. So I just started typing in N. I'm going to highlight that. All right, and then I'm going to save, and then I'll build. Right, and then I'm going to run it. Oh, there we go. Now we've got our same window, but now our text is in magenta color. All right, so that ends this. We're going to go with the Mac. I hope this lab works out well for you and that you enjoy working on it.